And next we have Bojan Pejic of Siemens Energy.
So my name is Bojan, standing here in front of Siemens Energy, working as a business development manager responsible for the Southeast European market. And actually I joined the company and this whole energy sector now roughly 10 years ago. Started firstly in engineering, working on the design of combined cycle power plants, cogeneration power plants, meaning dealing directly with the heat systems. A couple of years later, I switched to the sales position where I was again responsible for the gas turbine portfolio, combined cycle power plants, and now as a business developer, focusing on a very similar topics. So I just wanted to say with this that throughout these 10 years, I was dealing directly or indirectly with heat systems and decarbonization of heat systems. And now, as we are gathering here, let's say, energy intensive sector, I believe many of you are also active in the energy sector, and you are, I guess, kind of aware that heat is a large contributor to the global CO2 emissions. We do know that in the region, in directly neighboring countries, we have many countries where coal still plays a significant role in the energy mix. But although we are all aware that we emit a lot, actually, I also have to admit I was not aware what the exact number is, so I did some research. And actually, heat production is responsible for 40% of global carbon dioxide, so CO2 emissions. Sustainability, I think there is no need to discuss it much. I think we are all aware that all of our today's and future projects have to be sustainable. But then again, we also cannot rely only on the goodwill to make them sustainable. Here we also have policymakers, also something which was mentioned by Pierre in the initial keynote, which are either providing subsidies for decarbonization projects, or on the other hand, they are implementing and increasing year by year the price of CO2 certificates, meaning that now we are slowly coming to the break-even point, or even crossing this point, where it gets even more expensive to run CO2 intensive system than to invest into a decarbonized system. And third topic is flexibility, something which was also touched by Martin in his previous presentation. We live in a very fast-paced world, so it's a dynamic world where we get information within a second or millisecond. So this can also be translated to the energy systems. We are getting more and more powered by renewables, where we are kind of dependent on the fact if the wind is blowing or not blowing, sun is shining, not shining. So we need robust systems, which are also at the same time flexible. But the good news is it doesn't matter where your starting point is. We have industries which are at the very beginning of decarbonization, which we have industries which have made some steps. And now speaking in front of Siemens Energy. So we have Siemens Energy as one of the, let's say, significant players in this arena, with a lot of knowledge, with a lot of experience to help you to shape up your projects and guide you on the path to full decarbonization. I like to compare this, bring let's say, a real life example, maybe to make it easier to understandable for everybody. For example, if you're planning a trip, you want to travel from Paris to London. Of course, you can take a plane and fly there. You can board a train. There is a train connection between Paris and London. You can take a car and then you will be transported through the tunnel below La Manche and then drive a car again. In theory, you can also walk and swim, but I think you can all agree that some ways are more affordable than the others. Some ways are faster than the others. And let's say some ways are better than the others. So this brings me, let's say, to the next part of the presentation, where I will try to put spotlight on a couple of selected technologies which are applicable for heat production systems. Possibly this might give you inspiration for your future, let's say, endeavors within your companies or within your organizations. And if you recognize something, if you have project in the pipeline, feel free to contact me or my colleagues from Siemens Energy, and we will try to find a applicable solution for your needs, either by selecting product from our portfolio or guiding you with some of our partner companies. I would like to start this overview with, let's say, simpler adaptations which can be done by showing that you do not have to blow things up and do some large scale projects to reach this decarbonization. Every step counts. And later on, I will switch to some technologies which may require a bit more planning, a bit more efforts. On this slide, you can see as a title, brownfield engine exchange. But basically, we do not have to limit ourselves to the engines. Basically, if you have a running system, be it a gas turbine, be it a steam turbine, heat recovery steam generator, or whatever you have in your system, there is always way to optimize. So for example, in this case, if you have an, let's say, older gas turbine, which is not anymore state of the art, you can exchange it. You can, if you have a steam turbine, you can exchange the blades, or you can exchange the whole turbine, make it more efficient. And by improving the efficiency of a system, you will optimize your fuel consumption. So you will either produce more energy for the same fuel consumption, or same amount of energy if you need it, but by using lower fuel. Basically, what I'm trying to say, you do not have to scrap all of the existing systems. There is always a way to improve it with fairly reasonable investments, and in that way, improve your CO2 footprint. So here we are talking, of course, about partial decarbonization, where by improving certain steps of your process, you can make start your path towards decarbonization. Very important topic, especially relevant for our region of Central and Southeast Europe. As I have mentioned before, we have several countries with significant role of coal in the energy mix. And just to put some spotlight on coal or difference between coal and gas, just if you compare coal and gas as fuels, if you substitute your coal system with a gas turbine, so if you run natural gas, you can already reduce your CO2 footprint by 50%. Meaning if you connect a gas turbine to a hot water boiler or heat recovery steam generator, you already drop significantly, so by 50%, your CO2 footprint. And very, very related to the topic of coal to gas shift, you can furtherly, let's say, make your system more efficient. So if you have operating gas turbine, which has very high temperature of exhaust gases, you can use this high temperature to convert water into steam within heat recovery steam generator, run the steam turbine, basically creating a combined cycle out of which you can take hot water or industrial steam for your processes. So basically, I think this is known to most of you, but with this you can reduce the CO2 footprint by 70%. So just by switching technology or making the fuel shift from coal to gas, you can reduce your CO2 impact by 2/3 or even more than this. Of course, 2/3 are not enough. So our final target is reaching the full decarbonization, going to this net zero. And I think many of you have been dealing with the topic of hydrogen, or at least heard about hydrogen as an alternative, as the future, as an upcoming technology, which can then in a mid or long term replace natural gas. This is all correct. I think hydrogen is a topic where probably we would need a separate session to discuss about it. But yes, hydrogen is a fuel. It's a gas, it's a flammable gas, which can be used within the gas turbines. And here I would just like to point out that our gas turbines are already capable of burning hydrogen. So you can blend hydrogen to natural gas through various levels. In that way, you can reduce your CO2 footprint furtherly. Or if you're burning 100% hydrogen, you can completely, let's say, eliminate CO2 emissions. We have various gas turbine models. Some of them, depending on the type, we are able to burn between 30 and 75% of hydrogen in the mix. But we also have a clear commitment that by the end of this decade, all of our gas turbine models will be ready and capable of burning 100% hydrogen. Also, good thing is each gas turbine which we sell today will be able to be adapted in the future on site to burn 100% hydrogen. And as I was saying, hydrogen has, let's say, got quite a lot of attention in the last couple of years. You can see articles and conferences about it basically everywhere, already today or in the future. Low carbon gas fuels, which do get attention, but maybe not as much as hydrogen has gotten in the last couple of years. Those fuels include either synthetic fuels, such as e-methane, e-methanol, and so on, geothermal sources, which can either be directly extracted into the system, so you can directly use hot water and pump it, for example, in a district heating system, or you can combine it with a heat pump, so utilize it for heating of systems in winter, and vice versa, cooling of buildings, for example, in summertime. Those couple of technologies I have mentioned, they all relied on some kind of fuel. So be it coal, natural gas, synthetic fuels, biomass, whatever. But there is also strong tendency nowadays to electrify processes. So to get away from, in cases very suitable, to get away from this, let's say, fuel burning. So we talk about so-called power to heat processes. One of the main, let's say, the most known examples are the heat pumps, where with electrical input, you can generate 2, 3, or more times higher thermal output. And here we do not even talk anymore about the efficiency of the process, because obviously we can't have more than 100% efficiency. So we talk about coefficient of performance, which can be 2, 3, or more, meaning that we get more thermal energy than what we have put into the system, like, let's say, electrically. This is also something which is covered by Siemens Energy. So we do have heat pumps in our portfolio. And those are systems which are capable, especially for the district heating systems, for temperatures until 100, 120 degrees, maybe even 150. If you need slightly higher temperatures, if you talk about 250, 270 degrees for industrial processes, you can then add compressor and also reach higher temperatures. However, we also have industrial processes which require much, much higher temperatures than what we are talking in the case of a heat pump. So here we have a couple examples, starting with electrical boilers, which use heating rods and electrodes. Here we talk about temperature levels of 300, 350, 70, which is achievable, and they do have efficiency of close to 100%. But on the other hand, we also have other energy-intensive industries, such as steel production, cement production, and so on, where we talk about temperature levels up to 1,000 Celsius degrees. So here we need a bit more planning, with a bit more effort in designing those systems. But two suitable technologies for those processes would be either induction heating or turbo heaters. So what I would like to offer you as a kind of a wrap up is, let's say, so-called cheat sheet. I try to take this couple of selected processes to show which technology may be suitable for your application, depending on the temperature levels which are needed. So if we talk about, let's say, lower temperature levels, as I have mentioned, of 50, 100, 150 degrees, this can be easily achievable with a heat pump. But also coming back to the story of combined cycle power plants or cogeneration power plants, this can also be achieved by extracting steam or hot water from the steam turbine part or directly from the boiler. Coming back to my last slide, so we have some let's say chemical industry or other industries where temperatures of, let's say, 300 to 400 degrees are necessary. There we would probably go for electrical boilers. And then, as I said, some petrochemical processes, glass, cement manufacturing, steel making would require planning of induction heating and turbo heaters. And maybe what is not here on the slide, but it was a good note from one of the previous presentations this morning, is also the utilization of carbon capturing. So maybe this is not directly a topic for today, but you can also plan furtherly. If you have CO2 intensive process, you can also add carbon capturing system. So this may temperature levels where possibly more investments and more planning is needed. I tried to scratch the surface of selected technologies which are available on the market. But of course, if you have any project in the pipeline, if you have any projects in the planning, feel free to reach out. You can make a screenshot of the contact data and feel free to get back to me. I will try to support or at least try to connect you with our experts within Siemens Energy. So thank you.
Yeah, super.